A current carrying circular coil of radius capital R has a point P situated on its axis. P is a point on its axis at a distance x from its center O of the coil. So here we are having a circular coil of radius R, O is its center and P is a point at a distance x from its center along its axis. Now the magnetic induction at point P, magnetic induction at point P is 1/8 of magnetic induction at its center, magnetic induction at the center O of the coil. Then the value of x is, now we know very well that what is the magnetic induction at any point P along the axis of a circular current carrying coil such that point is situated at a distance x from the center O. It is given by formula that magnetic induction at any point along its axis, it is mu 0 ni into what? A square divided by 2 in bracket a square plus x square raised to 3 by 2. Remember here, a represents the radius, which in present case it is capital R. So it is mu 0 ni into r square divided by 2 times r square plus x square raised to 3 by 2. So this is magnetic induction at any point P at a distance x along the axis of coil from its center. Now we want to compare it with magnetic induction at any magnetic induction at the center of circular current carrying coil. We know magnetic field at the center of magnetic field at the center of current carrying coil. What is the formula for magnetic field? Magnetic field at the center of current carrying coil is given by BO, because O is the center, is equal to mu 0 ni divided by BO is equal to what? Mu 0 ni divided by mu 0 ni divided by 2r. Here radius is r, so mu 0 ni divided by 2r. This is equation number 2. But we want to find out the value of x, and we know the relationship between magnetic field at a point along the axis to magnetic field at the center of current carrying coil, that BP is equal to 1 by 8 that of BO. Now put the value of BP and BO from equation 1 and equation 2. So we have mu 0 ni into r square divided by 2 times r square plus x square raised to 3 by 2 is equal to 1 by 8 into mu 0 ni divided by 2r. Mu 0 ni divided by what? 2r. Now see what can be cancelled. Mu 0 on both sides, n and I on both sides get cancelled. Now cross multiply. So what happens? 8 into 2. It is 8 into 2 is what? 16, or you can cancel this 2 with 2. So we are left with, therefore 8 r and r square. So it is 8 r cube is equal to 8 r cube is equal to, take this to this side, so it is r square plus x square raised to 3 by 2. Now 8 r cube, it can be done as 2r whole cube, because cube of 2 is 8 and r cube. 2r cube is equal to r cube plus x square raised to 3 by 2. R cube x square raised to what? 3 by 2. Now taking cube root on both sides, so we get 2r is equal to what? 2r is equal to r square plus x square raised to power what? 1 by 2. R square plus x square raised to power 1 by 2. Now take square on both sides, so it is 4r square is equal to r square plus x square, or 4r square minus of r square is equal to x square. or 3r square is equal to x square, or root 3 into r is equal to x. So finally we had the value x is equal to root 3 times the radius of a coil. So out of 4 option, which option is correct? Look at option D. It is the root 3 times that of the radius of a coil. So D is the correct option for this question.